Good evening, everyone. So we know that in last class, I think we are studying presently gravitational potential energy. Am I right, everybody? Yes, please. So gravitational potential energy, we have been found two different definitions. One is, anyhow, we cannot define a potential energy for a single body. So always we can define a potential energy for two bodies. That is also not potential energy. What we can define always, everybody? It is not possible to define a potential energy of a body. Always we can define what? Change in potential energy. So that is what we got the formula. Change in potential energy is equals to minus capital G into M1 into M2 divided by distance between them. That is what R. So this is the formula, we got it. Change in potential energy. So change in potential energy is equals to, we know the formula, that is what? Minus of work done by the gravitational force in bringing how much mass, guys? In bringing each mass m from where to where, everybody? Infinity to from that configuration. Understand? So that is what we do. From any mass, if it is at infinity to particular point, if I want to bring it. So that is what? The negative of work done of bringing the mass m from infinity to A is called it as a change in potential energy, or which is equals to positive, that is what? Plus work done by the what forces, everybody? Work done by the external forces. It is equal positive of work done by external forces or negative of work done by the gravitational force. Work done by the gravitational force on bringing of mass m from every mass, each mass from infinity to particular configuration. That is what point is called it as a change in potential energy. So now this change in potential energy, we have been seeing the formula. So if there is a three objects, like three bodies or three masses are present at equidistance, or the four bodies are present for a square or rectangular, edges of a square or rectangular, or if there is more number, like if you have taken hexagon, pentagon, heptagon, like if it is keep on going, so like n is equals to 3, n is equals to 4, 5, 6, 7, like that, so on, then we have a formula for calculating the total potential energy. So minimum how many bodies has to be involved? Two different bodies need to connect it. And what is the formula we have been done, everybody? If n is equals to so on, it is falling. So what is the formula? Everyone, mathematics formula. So what is the formula? NCR, which is equals to n factorial divided by r factorial into n minus r factorial. So this is what we have to find it. So number of configurations to derive the total potential energy, change in potential energy of a system. So that is what we have done. For example, n is equals to 4. In the last class, we have done. How many configurations will come? Everybody? N is equals to 4 means. Yes, how much? 6 configurations. So 4C2. Because minimum 2 bodies has to be there. Configuration is always possible, not possible with a single body. So single body, it is not considered. Always a pair of body we have been considered. So configuration is 2, 4C2. So what is the number of configurations? 4 factorial divided by 2 factorial into 4 minus 2 factorial. So which is equals to 4 factorial divided by 2 factorial into 2 factorial. So 2 factorial, that's what I can write. 4 into 3 into 2 into 1 divided by 2 factorial means 2 into 1 into 2 factorial means 2 into 1. So 2 will get cancelled, 1 will get cancelled, 4 3s are 12. 12 divided by 2, which is equals to how many configuration? Everybody? Configuration. So we have already done. Now, if I have taken a hexagon, we are going to solve the question now. Hexagon. So we all know that hexagon means 6 side, n is equals to 6. So 6C2, if I have done, how many configurations we got it, everybody? 15 configurations. That is what will give you the total potential energy. So change in potential energy. Now, today's class we are going to continue with this concept. So please remember what is the change in potential energy formula, everybody? Minus of G into M1 into M2 divided by R. This is the formula for change in potential energy. Remember today's class also you need this formula, and next concept what we are going to study also the same formula will be useful for us. Now, Observe very carefully. Are you all there in meeting? I think most of them are there. Mr. Rishi, Sai Karthik, can you hear me? Everybody? What happened to Rudreswar and Pradoshe? Both were not there. Okay. So observe very carefully here. So there is a three bodies. Each mass is m. M and another m and another m. So now you all can notice it, everyone, having a distance of a between them. That is what equilateral triangle. Now, I want to move this body mass m from this place to, so another system of mass, which is m, but a 2a distance. Each one is how much distance, everybody? 2a distance. Clear, everyone? So I want to move it from here to here. So what is the work done? Work done by us? That is the question. So what is the work done by us to transferring the mass m from here to here? That is the question. So let us see how to solve it. Let me teach you. Later you will understand. So options also I am giving you. So option C is option A, 2gm square divided by 3a. Option B, 3gm square divided by a. Option C, 2gm square divided by a. Option D, 3gm square divided by 2a. So let me see, everybody, what you can try. So you can try the formula. Change in, because externally we are doing, because we are transferring the mass from here to here. So I will consider, everybody, work done by the external forces is equals to change in potential energy. So change in potential energy equals to work done by the external force. This is what is the formula. Clear, everyone? Understand, Ara?
Yes, sir.
So now we want to find this work done. So means we need to know the what? Initial potential energy and final potential energy, because delta U means what? Final potential energy minus initial potential energy, which is equals to positive of work done by the external force. That's all it is now. So if I find the initial potential energy and final potential energy of a system, and if I substitute it, I'll get the answer. Am I right, guys? Please respond. All of you?
Yes, sir.
That's all. So now, what is the initial potential energy of a system? Check it, everybody. Initial, this mass I want to transfer. So initial potential energy is what? Anybody? Yeah, A is the distance. Potential energy, ma. What is the formula? Everybody. Three bodies are there. See, connecting. 1, 2, 3. One body means, anyhow, this body means, what will happen? You all should speak. Three bodies are there. So 1, 2, 3. So 3 times of. 3 times of. How much it is? Any two bodies, A is the distance between them. So what is the? Minus G into M divided by A. Am I right, Ra? Respond, everybody. So 3 times of minus G into, minus will become M into M square divided by A. Any problem for anybody? Initial potential energy? Please speak, guys. Yes, please.
Yes, sir.
Yes. Now, final potential energy. So this is the final potential energy. So what is that actually? 2a distance, 2a distance, 2a distance. So what is the final potential energy of a system? Anyone? Final potential of an energy system. How much? 3 times of minus G into, again mass is same, M and M. So M into M square divided by, instead of A, what will happen? What will happen, everybody? 2A will come. That is the distance.
2a.
Because R is equals to 2A. That's all. So you can replace it, you will get it. So final potential energy is minus 3 times of G into M square divided by 2A. Next, minus of initial potential energy minus 3 into Gm divided by A. That's all, which is equals to positive work done by external forces. Any doubt? Anybody can ask me. Till here, any doubt, everybody? Are you clear? Understand, Amma? So that's all it is now. So
Yes,
take,
sir.
so minus of 3gm square divided by 2a, minus into minus, it will turn into plus. If you say it, will be very nice. Divided by a. So what is the LCM, everybody? Plus work done by the external force. What is the LCM? Actually, this is the shortcut formula. Please remember. This is the shortcut to find that one. Okay. So shortcut formula, we have to find it. So now you can see that. So what is the LCM, everybody? This is positive and this is negative. So let me write this one. So what is the LCM, everybody? LCM is 2a. So here minus 3 into G into M square plus 2 times of 3 into G into M square. So what will happen, everybody? Which is equals to positive work done by the external force. So this is plus 2 and this is minus 1. Like I will multiply with the factor of 1. So plus 1 minus 2, sorry, minus 1 plus 2, if you subtract it, how much is remaining? Anybody? Yes, please. Plus and minus, so plus will come. So 3gm square. Am I right, Pradosh? Are you there? 3gm square divided by a. So this is what is the total work done by the external forces. What is the answer? If you want, you can verify. This is minus 3gm square, and this is 2 3s are 6. So 6gm square. So what will happen, everybody? Gm square, I will take it outside. So 6 minus 3, it will come. So 6 minus 3, how much, Ra? 6 minus 3, how much? 3gm square. That's what I'm writing. Plus it is. So 3gm square divided by 2a. So that is the answer. So what is that option which is matching? Everybody. Option number D. That's all it is. So very simple. Write the initial potential energy. Write the final potential energy. So that's all. Apply always. This is the formula. Okay. So here R is equals to A. First case. Here R is equals to 2A. That's all. But masses is remain same. That is the advantage. M1 is equals to M2 is equals to small m. So you can easily finish it. Are you clear, everybody? Anybody having any doubt? You can ask me. Princey, understand, Princey? Nothing is there. Just
Yes, sir.
initial potential energy, final potential energy. That's all. Positive work done. That's what they are asking. What is the work done by us? That's all. Clear? Any doubt, Mr. Pradeep, Murali, Manya and Samya? Yes, please. That is what. Brothers, this much late. Rohit and Rudreswar and Narayan is absent. Okay. So any doubt, girls, please respond and do it, everybody. Make it quick. Any doubt, you can ask me. Are understand, guys? All of you?
Yes, sir.
Yes, sir.
So now, let us see, all of you observe. Next, this kind of things. Always, whenever you want to solve it. So you can go with this now. So you can see next, for example. Finish this question. Brothers, later. So mass M1 is there, having a distance of A1. Distance between them is A1, M1 and M2. So can you tell me what is the potential energy here? Change in potential energy. Everybody, fastly. Change in potential energy equals to minus G into M1 into M2 divided by A1. Am I right? A1. Now, this same mass as M1 mass, I have been shifted into 3A. Clear? So 3A1 distance, or else 3A distance. So now it will become here. This is. So now 3A distance. Now what is the final potential energy, everybody? Final potential energy equals to minus G. Yes, please. G into M1 into M2 divided by, instead of A, what will happen? 3A1. Am I right or wrong?
3A1.
Work done by the external force to bring this body from here to here is equals to change in potential energy. So this is the initial potential energy. This is the final potential energy. So final potential energy minus initial potential energy. This is what you have to remember. The most important one. That's what. Clear, everyone? Anybody having any doubt, you can ask. Okay, guys, everybody. So nothing is there. Work done is equals to final potential energy minus initial potential energy. That's all it is. Any doubt, you can ask me, or I'll solve this one and we'll go separate. Clear, everybody? Yes, please.
Yes, sir.
Pradosh, what is the problem? Mic is not working. Okay. Complete this, guys. Any doubt, you can ask. Okay. If you say, then we'll proceed. Manya and Samya also.
Yes, sir.
Yeah. Clear? Now, if you take, for example, Earth. So Earth is basically, it is not a spherical in shape. Of course, I'll consider a spherical in shape. Earth is a spherical in shape and having a small m mass is above present, just above present. Having a radius of Earth is r, we all know that, and mass of the Earth is capital M. So this is actually the Earth. Okay, everybody. Now, what is the question is, what work be required? What work be required to take m, to take m, which m, small m or capital M? to take M away from field of Earth. So if you want to take small m, which is away from the field m, that is what main capital M of Earth, then how much is the work done? That is what they are asking. Clear, everybody? So let's start now. All of you?
Yes, sir.
Yeah. Let us see now. Draw it, everybody. So start. So I will teach you. First you understand, later you can make it. Okay. So what is the initial potential energy? Anybody? Initial potential energy. Everybody make it quick. Initial potential energy minus G into small m into capital M divided by R. Am I right, guys? Am I right? Please respond.
Yes, sir.
Yes. Now,
Yes.
observe very carefully the screen. Answer is there in the question itself. What work be required to be take M away from the field of the Earth? Away from the field of the Earth means it will be reaches to the what distance? Everybody? What distance? Infinity distance means what is the potential difference at infinity? Everybody, whatever it is, 0. That is what the final potential difference. Over. What is the answer? Everybody, what is the work done? Work done by the external force is equals to change in potential energy. What is the answer, everybody? Yes, change in potential energy means what, guys? Final potential energy minus initial potential energy. Final potential is 0. Minus of initial potential energy is minus into small m into capital M divided by R. Over. What is the answer? Work done by the external force is equals to minus of minus plus. So capital G into small m into capital M divided by R. So this is what is the work done. Understanding? Which is required to take the any mass which is away from the field of Earth. Most important one. Please remember. Anybody having any doubt, you can ask me. Finish it, everybody. Clear it. Kadir, understand, Kadir? Make it quick. So this is the point which you need to remember here. If anybody will goes to the infinity distance, water voltage becomes 0, potential difference also becomes 0. Clear, everyone?
Yes, sir.
Yes. Okay. So now, based upon this concept, I will give you the question. Let me see who will solve now. After that, I will teach you. So write it, everybody. So unless you have to use all the concepts what you studied till now, it is not possible to solve this question. So let us make that question. And somebody is leaving and joining, leaving and joining. Who is that? Rectify your internet connection. What is this? Rishi, can you able to concentrate? Samaya, Manya, everybody. So read the question now. Everyone, everybody has to try. So let me take 1 kg object is present at a distance of 1 meter from another 1 kg object. So both are same mass. Whose initial velocity is 0? That is also I am saying you. So whose initial velocity is how much? 0. And the distance between is 1 meter. Now, somehow they have been both are attracted to each other. Initially they are at rest, attracted to each other, and they came, the distance between them is 1 kg. Sorry, 1 meter, 0.5 meters. Now, at this time, what is the velocity of this both bodies? That is what is the question. Clear, everybody? Understand, everyone? So write the question now. If the both masses come closer to 0.5 meter, 0.5 meter, from where it will come? Everybody, from 1 meter separation. From 1 meter separation, find the speed of. See, when they are kept at 1 meter distance, their initial velocities are what? They have been kept at initially at what? Initially, they are kept at 1 meter distance. The initial velocity of a system is what, everybody? 0. That is given, I am giving you. So find the speed of each mass. Find the speed of each mass in new positions. Find the speed of each mass in the new positions if their initial speeds, if the initial speeds was 0. Make it quick. Write the question and solve. Just to make an assumption and you Can you hear me, everybody? I'm not speaking. I
Yes,
just
sir.
mute myself now. Yeah. You can hear me now, I think. Yeah. Options. Do you want options? Not. You can try. Anybody answer, please? Are you trying at least? So it's very simple. Even you can make the assumption here. So they're asking what is the speeds once the distance is become 0.5. Okay. And what is that velocities they're asking? And they mention in the question, what is the initial speeds, everybody? What is the initial speeds, everyone? 0. Am I right or wrong? Everyone, please respond. So let me
Yes, sir.
make the assumption now. All of you observe. So assumption is only gravitational force in play. Means we are going to consider only gravitational force, no other forces, weight, friction, only the force which we are considering is what? Yes, please. Gravitational force. Clear? Understand, everybody? So now, so you can see initial velocities is 0, final velocities we have to find it, so we can apply that. Of course, gravitational force alone, it is what conservative forces alone is accepting. So we can apply the concept. What is the concept we can apply? Conservation of mechanical energy. So conservation of, what is the conservation of mechanical energy, everybody? Initial mechanical energy is equals to what? Final mechanical energy. So now, first, what is the initial potential energy? Of course, initial velocity is 0. So that initial kinetic energy is what? Everyone, initial kinetic energy is what? 0. So what is the initial potential energy? Both are at 1 meter distance and both masses is 1 kg and 1 kg. So what is the initial potential energy? Make it quick, guys. Minus G into 1 divided by 1. Am I right, guys? Please respond. M1 into M2 divided by R. Yes or no? All of you. So minus G into 1 divided by 1 plus 0, which is equals to final potential energy. So finally bodies came into what distance, everyone? 0.5 meters. So what is the formula? Minus G into M1 is 1 kg, M2 is also 1 kg. Distance is that 1 into 1 divided by 0.5. Purima ellame? Yes, please. So
Yes, sir.
minus G into 1 divided by 0.5. You say only it is. Now final kinetic energy. Two bodies are, both masses are same. Means we can say both are having the same speed or different speed or, because both are symmetrical. They are symmetrical system. So symmetrical system means what will happen, guys? Both will be having the what? Same speed. Understanding? So that is what. So I will write half mv square, half into m is 1 kg into v square is v square. That is what velocity square. But how many bodies are there? This is one body and this is one body. So that is why I have to multiply with what? Everyone, I have to multiply with the twice. Clear, everybody? Symmetrical system. Understand, Pradosh? I'm calling you. So which will be solve it. So minus g is equals to here minus g divided by 0.5 plus it will turn up into what will happen? Half into 2 into anyhow it will be getting cancelled. So 1 by 2 into v square into 2. So 2 will get cancelled. Am I right? You should speak, guys. That's all it is now. So now you can see minus g, if it will 0.5 will come this side. What will happen, guys? 0.5 will come this side. It will become multiplication. Am I right or wrong? Please respond. So minus g plus half gone, which is equals to v square. Now minus g into 0.5 g minus, which is equals to minus g plus v square. So v square is equals to minus 0.5 g minus g will come this side, will become what, everybody? Plus g. So which is equals to 0.5 g is remaining. So that is what v square. So we all knows the capital G value. What is the capital G value? 6.67 into 10 power minus
10 power minus 11.
Newton meter square per kilogram square. Units, if you don't know, there is no use of learning that value. Newton meter square per kilogram square. We already studied at the beginning of this chapter. Can you able to understand, everyone? Mr. Rishi,
Yes, sir.
Pradosh, Murali, Kadiri, that is what. So V is equals to root over 0.5 g. So that is what is the final velocities of the both bodies. So because both bodies are symmetrical, so their velocities are remains same. That is what you have to remember. Anybody having any doubt, you can ask me, or else we'll proceed further. Are you clear, everybody? Yes, please.
Yes,
Yes,
sir.
sir.
Finish it. Every chapter, always the concepts what we studied, you need to remember it. That is what is that. Always we need to learn what, always you have to remember what you learned already previously. Anything doubt in this, you ask me. Don't know what is happening. Many people are, they are not all doing, I know very well. So just do it, everybody. Mr. Rishi, are you trying? Pradosh, any problem, Mike? Okay, so do it. Next one, you can take it. So two masses are there. All of you observe, this mass is M and another mass is also M. But check it, Amma, this question. If you have any doubt, you can ask me. Are you understood, Amma, this question? Everybody?
Yes.
Yes, sir.
Solve it. Any doubt, please let me know. Then only I'll proceed further. So that is what. So assumption we are making only gravitational force in play. So that is why I am taking immediately. It is a conservative force. So conservation of mechanical energy. So initial mechanical energy is equals to final mechanical energy. Over. Any doubt you can ask. Shall we proceed now?
Yes, sir.
Yeah. We'll do it, guys. Everyone ready?
Yes, sir.
Yeah. Okay. So now you can see. You have noticed it. So I'm taking a two bodies where the axis of rotation, let me take it as exactly middle. So there another body is attached like a pulley questions. Now this is from the axis of rotation at a distance and this is from axis of rotation again at a distance. Now this body is like a pulley. So where you can see which has been exerted by the attracted by this body also, which has been attracted by this body also, force. Clear? All of you understand? Everybody?
Yes, sir.
Yes. So now question is find the speed of capital M. See, these two are small m. I forgot it here. There is a mistake. This is not a small m. This is what m? Capital M. Remember that. Find the speed of capital M when it crosses the point P. It crosses the point P. Okay. Crosses the point P. If initially all the masses, if initially all masses are at rest and small m masses, small m masses are pivoted. Small m masses are what, everybody? Pivoted. Clear, everyone? Do you understand? So small m, both masses are pivoted so that their initial potential energy and their final potential energy remains what? They're pivoted, guys. So there is no change in potential energy. So what is that? Both are remain same. Am I right or wrong?
Yes, sir.
Yes. So now this is the question. So let us see how it will be. It's very important and very interesting question. Now the force is acting like a resultant force. Then by this time the force will be splitting into two components. What is that components? Which is making with the theta angle. So what will happen, everybody? This is x component. Another one is what component? Y component. Am I right? And this force is also, it will become what? X component and it will become Y component. So now both XX are horizontal forces and they are equal and opposite because same mass and same masses. So equal and opposite. So horizontal forces will get cancelled or not? Everybody. Horizontal forces will get cancelled or not? They will get cancelled. So this body M will move up only because of Y direction forces. In this, any doubt anybody can ask me? I will. Are you clear, everybody? Yes. And I forgot
Yes.
to mention here, this capital M body is X meters away from the two bodies. X meters away from the two bodies. And these small masses are, both are pivoted. Both are pivoted. Means their potential energy initial and their potential energy final. Is it remains constant or where is that? Anybody? Yes, please. I'm asking the question. If the body is moving upwards, you can see this, both the bodies are constant. So pivoted, there is no distance is changing for them. So is it their potential energy remains constant or where is that? That is what is my question. Everybody. No change in distance. Then what will happen? Potential energy will never change.
Constant.
Understanding? Potential energy remains constant. That is what. Next. As these bodies keep on moving up, as it see initially at x distance, next that it will maybe come to at this point, next maybe come to this point, next maybe come to this point, next maybe come to this point. Like you can say imagine free fall, like a free fall. So as the distance is distance, like we can say when the bodies keep on coming down, we can see the velocities keep on remains. Of course, the distance traveled by bodies keep on changes. So the velocities keep on increases. Before touching the ground, it will be having a maximum velocity. Am I right, everybody? Yes or no? All of you?
Yes, sir.
Yes. So same way, if this body is lifted off, every time there is a change in distance traveled by the body. So if it is going upward direction, as it is changes, the amount of force, suppose see, if the body is too deep, so initially they need more force to pull it up. Once the body will started moving, does it require the same force or it is a different force is required? Anybody? Yes, please. Initially at rest. So initially at rest means you all studied that like a rolling friction, static friction and all. So when the body tends to move and when the body is moving, where the frictional force is less? Everybody. The force is less in where? A body which is red tends to move or it is already moving. Everyone? Nobody is answering. Suppose the body is ready to move. A body is ready to move or now already the body is in motion. Now which is poses more greater frictional force? Everybody? It is ready to move. It is ready to move and this is already in motion. Which will possess less frictional force? Anyone? Worst like anything. So if the body is ready to move, that is what we used to call it as a static friction. That is what maximum static friction, which we used to call it as a limiting friction. So once the body started ready to move, so it requires maximum force to overcome that friction. Once it will started moving, then that is what we used to call it as friction, the kinetic friction. So we all people know kinetic friction is always less than the static friction. Am I right, guys? That is what limiting friction. So now same way, when the body is initially at rest, so the forces exerted by both the bodies will be definitely something. Now once the body started moving upwards, distance is keep on changes. So now the applied forces also definitely will be changes because initially at rest, so to bring it motion, they need to push on, they need to pull little stronger. After that, it will be definitely there will be variation in the force. So F changes. F changes with the time t. If you don't want to speak, please don't join. I'll stop the classes, everything. No problem for me at all. Even I am very, very tired. I don't want to make it anything. So that's what you have to remember. So F will be keep on changes with the time, because as it is the body is moving up, so we all knows that velocity changes. If velocity, like when the body is keep on moving, coming closer, so distance is keep on, it will be changing. So velocity is keep on increases, acceleration also keep on increases when the body is coming towards to them, like attracting more and more. So when you are very far, like the force of attraction experiencing is like very far less. Once you started coming to the near, then the effect will be more, so that the body more faster it will try to come to near to them. That is why the velocity increases, acceleration also increases. What I said, I hope you all understand, everybody. When body is going up, so that you can see the force of attraction keep on increases. Why? Because the bodies are coming closer. We all knows that. Bodies, any two bodies, distance is decreases. Force of attraction will increase, because F is inversely proportional to square of radius. Am I right, guys? Radius not distance between the two bodies. Am I right or wrong? Please respond.
Yes,
That is
sir.
what we used to call it as
Yes,
a
sir.
inverse square law. Universal law of gravitation, we studied that. So when the body is at far, these two bodies are exerting force at a longer distance, so that the effect will be less. The distance covered by the body will be less. Now, when the body started coming closer, then the effect of force will be more, so that velocity increases and acceleration also increases.